what can you just tell me a little bit about yourself and how you got involved in the whole space exploration kind of gig?
Yeah. So right now I'm a senior lecturer in the School of Biomedical Engineering at the University of Technology, Sydney, and my research has predominantly, and my background is in cell biology. I've always, throughout my research career, looked at how diseases occur and obviously trying to understand the occurrence and how diseases happen in hope of mitigating these. So I think everyone would know that space is an environment where it accelerates the aging process, and we all know if it affects bones, particularly very dramatically. During my research years, especially during my time at Harvard, we worked on one of the NASA projects where we looked at development of countermeasures for bone loss with Amgen, one of the pharmaceutical companies. So right now, it's after all these years, it's officially released onto the market as an anti-osteoporotic drug, and that came from the backbone of space research. So really, when I came back to Australia and sort of started my own lab, I thought about, wow, this is quite amazing. How do we advance this area of science? Because back then, yeah, people understand there's effects, but no one understand the underlying mechanisms of why. They know it happens, but I want to understand why. So that's when I started developing the tools, because there's no tools and it's very hard to investigate something when you don't have the technology or tools. We developed what we call a random positioning machine, which is basically a simulated microgravity environment. And because of
Okay.
my background in cell biology, I understand what I need for me to do this research. And we started to develop tools, complementing accessories and little things, but it makes all the difference. So that's kind of a very short summary of a long story and journey in a nutshell.
And are they analog tools that are on in Earth, or have you got some experiments going on in
Yeah.
microgravity in low Earth orbit?
So that you're absolutely right. So the point of purpose of this development is so that it is an analog tool that we can simulate microgravity down here on Earth. What I The way I think about it is really to optimize experiments for low Earth orbit, because as you can imagine, experiments on low Earth orbit is all one timely, two costly. So what we are really essentially providing is a de-risking future life science payloads, because you want to make sure the experiment you're sending up there is fully optimized to, really take advantage of that environment rather than go up there and this didn't really work out. So, all that time and money just went down the drain.
So was it the medical curiosity that led you into space, or were you a bit of a space nerd as a kid?
I think like anyone else, I'm a big sci-fi person, love all my predators, aliens, and whatnot. So I think like everyone, there's a natural curiosity of space. And I think, I just be in that Harvard environment where, where we're trained to have that nothing is impossible mentality really help inspire me to really, how do I push this forward and advance this area of medical research?
And do you think that the research you're doing, are you trying to come up with treatments and cures even for earthbound problems at the same time, I guess, as also looking at increasing the detrimental effect that space has on our astronauts?
Yeah, absolutely. I think this is one of the beauty of what we do as space biology is that there's that two phase applications to it. One is obviously the accelerated aging process, mirrors the conditions, a lot of diseases down here on Earth. I always tell people it's if I suddenly beam you to Antarctica, you're gonna feel real cold and shiver. And that's the response we want, because diseases don't have any genetic memories of being in that environment. So they're gonna either respond to it or respond very aggressively. And that helps us unlock some of these mechanisms. And I always tell people, North Face, just because they build winter coats doesn't mean they have to build it in Antarctica. They understand that environment and use that environment to test their coats for other very normal, winter type of conditions. So that's also what we're trying to do, is really leverage that environment and that response from these diseases to really understand how they respond and how we can understand and hopefully develop treatment for it.
In terms of the average person, so not just treating people who already have the disease process going on, But what's the implications of kind of the edges of what you're looking at for just increasing the longevity of life expectancy for just the normal average human being?
So you raise a really good point because right now, most of disease research is studying diseases after they've happened. If someone's were to get cancer, get COVID, or whatever. But what microgravity does is that we get a glimpse of how it got there. By understanding how we deteriorate into this disease condition, we can develop preventative medicine. And that's what everyone's trying to do to prevent bad things from happening in the first place. But you can have all the best AI drug screening panels on the world, but if you don't have targets, it's really hard to develop these preventative medicine. So I see it as an added tool, a complementing tool to drug discovery, understanding how we can prevent diseases in the first place. Because, for example, you and me, we all know exercise is good for you, especially as you get older. But why is it good for you? What's the thing that ticks in our body that makes it good for you? So that's what we're trying to figure out.
Do you expect to go into space?
I sincerely hope not, because once you're at this research, you know what it does to
Okay,
you.
you do.
So yeah, I'm quite happy to be here on Earth.
Okay, okay. So even a day trip up to above the Carbon line and back down in an afternoon, that's not particularly appealing to you.
Day trip is fine. Day trip is fine. But anything longer than
Okay.
like a week, I'll probably be a bit worried. Yeah.
So where do you see the research you're working on and the whole longevity thing in 200 years' time, given 200 years to develop it? Have you thought on that sort of time horizon?
Yeah, it's actually quite fascinating to be able to think that far ahead in the next couple of generations. So if we are looking at that kind of 200-year scale, I think there will be a lot of diseases that are no longer an issue. And I do see us being fully capable of going beyond Mars, to be honest, living successfully beyond Mars. So I think within this time frame, lots of exciting things are going to happen because we have reached a point where a lot of these tools and technology can be accelerated. And we're just seeing this as a emerging, but now more than ever, a lot of people are starting to appreciate and understand the complexity, but also the opportunities that comes with it.
I think it's fascinating. Let's say in 50 years' time, there may well be a colony on the moon and maybe a colony on Mars, but there's still be somewhere in the region of 9 billion people on Earth and
Yeah.
a few hundred people on Mars and on the moon. But if you extend it to 100 years, I don't know what the numbers will be, maybe not significant. When you start thinking 300, 400, 500 years, okay, now we could have quite a significant number of people
Well,
actually living in space, never lived inside a normal planetary system. And I just wonder how the bodies will evolve, naturally evolve when they're put in those types of environments for that period of time. It's fascinating what time does for perspective.
Yeah, absolutely. And I don't think, yes, there'll be a certain level of, physiological adaptation to the, local environment, whether it be the moons, Mars, or low Earth orbit. But I think it will be more in terms of we've developed technology to mitigate those side effects. So as you mentioned, lack of gravity, we'll be able to compensate for that through either artificial gravity suits or, design of buildings. So I think it is about mitigating these side effects. To some extent, we will evolve and adapt to certain environments. And you have to take into account, we are also advancing quite quickly gene editing. If we identify certain genes or pathways that is more susceptible to the effects of, then there's every possibility in the next few hundred years for us to be able to either protect or mitigate those gene expressions.
Some kind of like mRNA type
Yeah,
intervention.
yeah,
Yeah.
exactly. Some genetic
Yeah.
therapy or genetic editing to help us cope with that kind of environment.
So what's the big news with you at the moment? What's the kind of the big thing that you're working on or involved with your company?
Yeah, absolutely. And as I mentioned, because we're I guess a leader in this pioneering leader in this area. So we are developing a lot more of the core technology. And as you mentioned, there are more interests about the moon, Mars. So we have been developing new simulators to simulate those environments and really to understand, the the cellular response under those environments. Because, for example, on the moon dust is a big respiratory problem for anyone.
Yeah.
We have research that looks at what are those effects, how do we protect against those effects, and of course, radiation. There's a lot of work on that front. How do we mitigate or protect our body from the effects of solar radiations and whatnot? So there's a lot of work to do. I think we're just barely scratching the surface, but that's the exciting part because there's a lot of opportunities. More people are likely to join in, and we're seeing a lot of activities in this area. And we organize the world's biggest humans in space conference every year. We have seen significant increase of participants. So that also, is a reflection of, people's interests, but also the importance of this area of research and development.
The conference that you're organizing, the Humans in Space conference, when is that?
This year, it'll be on November 7th and 8th. It's international. So we have people all the way from NASA to JAXA to ESA to ASA it's a very global community, and it's a very diverse because if you think about humans in space, there's a lot of aspect to that. This is not only about biology and health. We're also talking about food. How do we get nutrition? And of course, technology, the economics of it, the mental health, the law. So it is a very diverse conference. So that's why I think people are very fascinated to participate in these type of discussions.
And the conference itself, is that in Sydney?
Yes, so we have 2 days in person and then 3 days that are virtual because we have a lot of international speakers. So we try to cater for everyone in different time zones.
So if you had leaving thought to leave with just the normal general population of the planet, not particularly scientists, not particularly medics, but are not particularly aware of what's going on in space, what would be the one message that you can think of? Sorry to put you on the spot like this, but what would be the one message that you'd really like people to just think about a little bit?
I think it's also for myself is really don't be limited by the impossible. Really push yourself out there. I have to admit, when I first started this and developing the tech and talking about this research, everyone thought I was crazy. They're like, this will never work. Like, you're nuts. But 4 years down, this is something that everyone is talking about and raving about right now. So I think if I have a message to everyone, especially younger generation, is don't give up on your dreams. And just because someone says impossible doesn't mean it's impossible. And I've had a lot of people, thank me for organizing this conference because they finally have a platform to share their thoughts and ideas. So I really encourage everyone to really think outside the box and out of this world as well to really solve the problems we have in this world and beyond.
So that's absolutely fantastic. Thank